Okay, now let us learn about one more interesting properties of the square numbers as to how they relate with sum of odd numbers. So let us say that I would like to take the sum of first n odd numbers. So let us start with the first odd number, which is 1. So there is nothing to sum it up to. Now, what are the first two odd numbers, right? First n. So we'll increase where n goes from n equals 1 and so on. 1, 2 odd numbers, 3 odd numbers, and so on. Now let's take two odd numbers. So the first two odd numbers are 1 and 3. So we say 1 plus 3 is 4. Now let us take the third odd number, three odd numbers, that is 1 plus 3 plus 5, and that the addition of this would be 9. Let us take the sum of first four odd numbers, so which would be 1 plus 3 plus 5 plus 7. So now 9 plus 7, actually you can just add this one to 7 and you get 16. Let us take next sum, that is sum of 5 odd numbers, and that gives you 25. And you can actually keep on doing this for for more numbers, for any any number of odd numbers. Now do you see a pattern emerging over here? So when you see the sum, the first odd number, the sum of first odd number, actually there is no sum here, but we can represent this one as 1 square. What about 4? 4 is 2 square, right? It's a square of 4. 9 is 3 squared, right? Similarly, 16 is a square number for 4, and 25 is 5 squared. So what is the pattern emerging over here? All we can say is that the sum of first n odd numbers equals to n square, which means, let us say that you have a number, let us say 9. Okay, you have a number 9. All you do is you could represent the square of 9, which is going to be 81, as a sum of first 9 odd numbers, which is 1 plus 3 plus 5 plus 7 plus 9 plus 11. So we have, let's say 1 plus, this is 3 numbers, another 3 plus 13 plus 15 plus 17. So you could represent the square of this number 9 as a sum of first 9 odd numbers. That is what this property is. Conversely, you could also say that a number is a perfect square if it could be represented as a sum of odd numbers, right? As a sum of odd numbers. So that is quite an interesting property which we are going to use later on in the chapter to kind of solve a few problems related to the squares.